Okay, we're making templates. There's my template. So, what I did here is I took the gearbox off, and then I'm using this top plate as a reference. So I put the square on like this and drew a line up here. Then I did the same on this side. Then I figured out the center. So that line right there is on the center line of that shaft. And I have a center line on my template, and I know that this center line of the shaft and the vertical dimension from this plate is 8 inches. So what I'm going to do is get this lined up just like that. Just like that. And then I know that that's in the center. It doesn't look in the center though. I'll have to check that out and make some measurements. But anyways, then I'm going to tap this thing so I can pick up the holes. These 2 holes right here. And that'll give me this whole dimension here. This whole pattern will be done at that point. So let me just take a look at this and make sure it's in the center, and then I'm going to do that. Okay, so I got my template lined up just the way I want it, and then I tapped it. You can see, like right there, there's like a slight imprint of the hole. Same over here. So now what I'll do is I'll measure this stuff and add it to my drawing and save this template for when we're really cutting metal. So this was the master one. This was the master thing, and it's gonna sit up. Try to show you this here. Okay, so this is the worm gear unit, and what this plate is going to do is sit at this surface, and this is going to be the back of the box, so everything will build off of this plate. And like I said, this is that 3/8 tooling plate, so what I'm going to do is tap down a couple of holes through that top plate, this thing, into here, and that'll anchor the top of it. And then these 2 bolts, these 2, I've extended with where did I put them now? Oh, here they are. These bolts, which extend out to the surface of that flange. They got little hexies on them to tighten them in there. So we're really not modifying the machine much. I mean, providing you have this metal plate up here. I suppose you could, you know, drill into the side of this thing if you located strategically where you could put some bolts. Passes and got this bad boy cut out. So let's clean it up now. Okay, so I got the back plate almost finished. You can see how it's going to fit in there. It's a real good tight fit around here, and there'll be 2 holes, one there and one there, and they line up with the holes in the casting, and that's where we'll put the spacers. So that's the next thing we gotta do. Alright, moving right along, got our 2 little screws. screwed into our spacers, and this thing is sitting at a nice angle for us. So what I've done is I've scribed with a carbide scribe around this. Now what I'm going to do is punch a few holes in here, and then what I'm going to do is put a transfer punch down through the top, get them onto this plate, and then we'll have that part installed. Okay, I got this one off of Brian Block. What you got to do is machine some pins that fit exactly into your T-slots, and then it's real easy to square stuff up with it. The only problem on this cheap ass mill is fits in this slot, fits in this slot. Oh, oh. I don't know, man. It's good enough though. Works good. Good tip. Thanks, Brian. Alright. We got our little mock-up thing going here. And I got this lined up so it slides really nice. So now we can take some measurements of all the little pieces we got to make to build this out. Okay, so we're just proceeding here. I rough cut these plates out on the bandsaw and then finished them on the mill, and just putting some holes in here to mount them to that plate there. So I'll be back with you when we start putting this thing together. Alright, so I got those two pieces mounted up. The next thing I'm going to do is make a plate to go across here that mounts the motor to it. And then I got one more plate to make for the top. And then we got to start building the shifter. Alright, so I figured I'd show you how I cut these plates. In order to keep everything perfectly square, the most accurate thing you got is the bed on the machine. So I do the clamp dance. As long as the plate, as long as your machine is big enough to cover all the areas of the plate, you're good. So what I've done is I've come down here, this clamp was on here, and I did this end. Okay, this plate is about 1/10 of an inch oversized, so I got enough to clean up the edges. Then I took that clamp off and I did this side. Now what I'm going to do is put that clamp back on here, take this clamp off, and use the DRO to get to my final dimension. And I'll do the same over here. And that way, when I take the plate off of the machine, all sides will be as accurate as I can get them, square wise and measurement wise. So there, that's how I do it anyways. Alright, we're doing the final side here. The clamps have done their dances, and as soon as we take off 167 thousandths more, we'll have a finished plate here. Okay, so now you can kind of see what I'm constructing here. I got one more piece to make. That's going to be a cover. And I haven't decided whether I'm going to put the shifter on the front or the top, but I have to think about that. So, the basic deal here is the back of this plate is exactly the right spacing to get the clutches to work. Alright, I've given it some thought here, and what I've done is to turn this piece of shafting to a length that when it's in there and lined up, it is just a little bit, just that little tip is sticking out. And what I'm going to do now is screw this plate on, and that'll give me the center of the shaft location without any measuring or anything. that is the center of my shaft. So we'll lay the motor pattern out on that and drill it out. Put the motor on there. And then we might be able to just slide the shuttle sideways by hand and see how the thing drives. Okay, so now that we know where the center of the shaft is going to be, we have to get the pattern of the motor that we're going to cut this plate for. So what I've done in order to square up the motor for this measurement, I basically have just put 2 screws in the mounting holes and bopped this thing back and forth between them until they're the same. So now I know that this motor is square to the table. So now I can use this pointer, this one right here, to go down in the center and then figure out what this hole pattern is, and then we'll cut it in that plate. Okay, so now you can see how this works. Right now I'm turning the worm gear, the handle, and this is when it's in neutral. Okay, so we'll be in neutral here. I'll turn on the motor, okay, and then I'll slide it. Now she's engaged in power downfeed, and I can get this thing, right now it's at 10 volts drawing at 200 milliamps, but here comes some juice. That's 20 volts. Pretty cool. So we have like really good control over that. Alright, finishing up for the day here. We got the box completely done. Got a bottom on it. Got it all cleaned up. And the innards are all there. The only thing I have to do now is put a shifter on this. So that's what I'll do tomorrow. But yeah, I'm pretty happy with the way it came out. It's solid. It's square. It's smooth. I was going to paint it, but I think I'll leave it. It matches the motif of my top thing here. So I haven't decided. I'll probably put the shifter on the top, but I'm still looking at maybe putting it on the front. I got to see if it'll interfere with anything, but yeah. So she's getting real close to being done now. Okay, so now we have to figure out some stuff here. And what we want to find out is what the shift distance is, and the easiest way to do that is to engage the clutch on the worm and then measure across to the teeth, and that turns out to be 23/64. Yeah, 23/64, which is about 3.359, so say 0.360. 360 thousandths is how far that has to shift from one to the other. Okay, so what I did is I put this box together without the motor on it, and this became my reference surface. I took my calipers and I measured into the face of the clutch face, the inner face, this face. And then through calculations and stuff, I basically came up with these two lines right here and This is the center line of the slot when it's engaged in the worm gear part, and this is the center line of the slot when it's engaged in the power feed motor. So the distance between these two is 317 thousandths, which is what the shift is. So what I got to do now is figure out this triangle, because I want to shift it. My total shift rail to rail will be 360. So I'm going to shift 330 so I have a little slop on either side so the pin isn't rubbing in the groove. Because what I'm going to have is detents in the top of this thing. So basically what you do is if you want to engage the power feed, you'd turn on the motor and then you'd hold the handle over to the right side until the clutch lined up, and then it would engage, and then you let go and it would fall back 15 or so thousandths into the detent, so it would still keep the clutch engaged, but you know, it wouldn't be rubbing on the side of this groove here. So yeah, we'll just figure this out, and then so there'll be a hole up here for the shaft to be in. I'm going to have a disc very similar to this. This is what I'm modeling it after. So, you know, there'll be this silver part will, you know, I'll turn up a steel one that looks like this on the top here. And then on the bottom face of it will be the detent ball. And you know, that's about it. So we just got to do some calculations, figure out where to drill and all that. Okay.